today we're learning to multiply and divide monomials. So let's start out by writing the definition of a monomial. Okay, a monomial is a single term or a group of numbers and or variables tied together by multiplication and division, but separated by addition and subtraction. So pause the recording and write that down right now. Everybody say monomial. 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 Now you can sing the song. Monomial. Do 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 do. Monomial. Do 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 do. Monomial. Do 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 do. Monomial. Do 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 do. Monomial. Do 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 do. Okay. All right. So this is going to be very important, the definition of it. It is a single term, one term. How do I know where the term ends? It is a group of numbers and or variables. That means it can be a number or it can be a variable. Or it can be both. It can be 5, it can be x, it can be 5x. Okay, it's tied together by multiplication or division. When things are next to, that means multiplication. So 5 or x or 5x or 5 divided by x. But it's separated by addition or subtraction. So when you see that addition and subtraction, that's when the monomial ends. So here's an example. Negative 5x, 3x squared y, 4/3 a squared. Negative 5 ab squared c over 2xy and xy squared. These are all samples of monomials. Now, there's a special name for the number that precedes the term. What is that word for the number that comes before the term? Coefficient. The coefficient, right. So we also have a bunch of coefficients here. The coefficient is the number that precedes a variable in a variable term. Precedes means before. Now, what is the coefficient in the first term? Go, Bryce. Negative 5. I'm glad he also uses the sign. Okay, the sign is part of the coefficient. The next one, Grace.
3.
Positive 3, good. Next one. The next one, let's go, Ashley. 4 over 3. The next one. Let's go, David. Negative 5 over 2. Look at how we find the coefficient there. And then the last term, Carter.
1.
1. It's not there, but it's there. 1 is the coefficient. Okay. By the way, what is the exponent of x in that last term? Go.
Also 1.
Also 1. We don't write it, but it's there. So if we're multiplying like terms, just remember it's there. Yes. Yeah. So the question is, what happens if I have negative 5a, b, 2c? Well, you wouldn't ever, the coefficient always comes first. So since this all means multiplication, that would actually be negative 10 ABC. So we always put our coefficient first. All the numbers that are getting multiplied go first, and that becomes your coefficient. Yeah. Okay. It's not negative 5 plus 2, it's times 2. That was not a bad question. All right. So number 1, is it, why don't you pause the recording and see if you can figure out which ones are monomials. Okay, now let's check our work.
Okay.
So, raising a quiet hand, tell me if number 1, 13, is a monomial. Max.
I do not think it's a monomial.
Okay, go back to your definition, read it. Read it out loud.
A single term, a group of numbers and or variables.
And or variables. A numbers and or. So is it a monomial?
Yes, it is a monomial.
Yeah, it could be numbers alone. It could be variables alone. It could be number and variable tied together.
Okay.
Okay, so number 1 is a monomial. Number 2, Dakota.
I think it's a monomial because it says Oh, no, because it's separated by addition or something.
Okay, so is it a monomial?
No.
No, it's not a monomial. There's actually how many terms there, Dakota?
There's 1.
No, monomial is one term. How many terms are there?
2.
2, A and 5. We know that the term ends when we see the plus sign or the minus. Okay, whereas in number 1, it's one term. Number 3 is one term because there's no plus or minus signs. Okay, is it, number 3, is it a monomial, Alan?
Yes.
Yes, why?
Because it's in one term.
One term and its numbers and variables tied together by multiplication. Number 4, please go, let's go with Harry.
I think it's a monomial, yeah, it is, because it's tied together by division.
And number 4,
Oh, shoot, I didn't see number 4. I didn't see it.
stand up.
I think it is monomial because multiplication.
Because it's tied together by multiplication. Number 5, Roman.
I think it is monomial because it's tied together by division.
Good. Number 3, go Eitan.
For number 6,
I'm sorry, number 6.
yeah, that's right. For number 6, it's not a monomial because they see addition and subtraction, and that separates it.
Good. How many terms are there? How
Um,
many terms?
There are 3 terms.
There are 3 terms. Y squared, negative 3y, and positive 9. Number 7. Number 7. How about Rebecca?
It's a monomial because it's one term.
Good. It's a monomial. It's one term. It's a variable. Number 8's a little tricky because I haven't really I haven't given you the full definition. I left a part of it out. I'll go with what do you think? Bryce, what do you think?
I think it is.
Okay, Rami, what do you think?
I think it is.
Okay. Carter?
I think it is not.
Okay, why do you think it's not and why do you think it is?
Because I think it said it has to have multiplication, and that's an exponent.
Okay, Matthew?
Oh, but isn't like if you do an exponent, wouldn't it be that times that like multiple times?
Yeah, it's actually not a monomial because the exponent has to be a whole number monomial.
I thought that was exponent.
This really means, and we will get into this later, this is the cube root. This is the exponent, and it means the whole thing is squared.
Oh, yeah.
So a cube root is like 8. The cube root of 8 is 2 because 2 times 2 times 2 is 8. So what times itself 3 times equals x? So it is not because you have to have a whole number exponent in order to be a monomial. Okay, so now we're going to continue. We're multiplying monomial times monomial. Okay, just a reminder, we're going to multiply coefficient with coefficient. So first I multiply 3 and negative 2, and I get negative 6. And then I've got a squared plus the second power. We're adding the exponents when we multiply, so it's negative 6a to the 4th. Questions? Yes.
So if it was just like a whole number for the exponent, it would be a monomial.
Yes.
Oh.
Going back. Okay, number 2, multiplying coefficients, it's 15. I'm going to remind you, this is x to the first power, and so it's x to the 1 plus 4 power makes it 5. We add the exponents, we multiply coefficients. Finish number 3 and 4. Pause the recording.
-4, 3, and -1.
Okay, 4, 3, and negative 1, and what did you get?
And I got 12.
Positive or negative?
Positive.
Positive 12, because I'm doing -4, positive 3, negative 1. Okay, and then for my exponents,
I added the exponent, so it's
2 plus,
plus 4 and then plus 1,
and that makes
7. So
7.
12 and the 7.
good. Next one, how about Julio?
You multiply 7 times 3, which equals 21.
How many A's?
There is 4 on one side and then 1 on the other.
So that makes A to the 5th, B to the,
First and B to the first. No, B to the second and then B to the first power.
and that makes,
B to the third.
Good. And c to the,
first and then c to the third,
and that makes,
c to the fourth.
good. And there we go. Questions? All right. So now we're going to add the last two nights together. You didn't know, you actually did this before, but we didn't know that these were each called monomials. So you see that this is our first term right here is a monomial times a monomial, okay? So that's basically what's different. But now we're going to put things together. Now, when you have power to a power, when multiplying monomials, we always do power to a power first. Okay? So, we're going to first do the power to the power. Mark.
So you multiply 3 and 2.
No, first start with the beginning number, left to right.
So you have 5y to the third.
No, 5 is not to the third.
Oh, 5 times y to the third.
Okay. Anybody else that can help me here? What am I doing in this, Matthew?
5 to the second.
To the second power, and then?
Y, and then it's to the sixth power.
To the third times the second. I don't want an answer. I want to know how to do it. Okay, and now I'm simplifying that. That becomes 25y to the 6th. Now notice I'm multiplying that whole thing by this next one. So what am I doing, Mark?
So you have -2 to the second
Power
times
and
y to the fourth.
y to the, what is the operation?
Exponents.
What operation?
Multiplication.
Am I doing 2 times 2 or 2 plus 2?
2 times.
Good. And that simplifies to?
-8.
It's to the second power, hun.
Oh, yeah. 4.
Positive 4.
And times y to the fourth.
Y to the 4th. Now, am I done? No. Now we go back to 2 nights ago lesson. And how does that simplify, Mark?
You have, so we multiply 25 and 4.
And that makes?
100.
And y to the 10th. We add the exponents here. Okay. Now you guys pause the recording and do number 2. Go. Let's continue. So now how do I simplify this first term? How about Dakota?
So I did 3 to the second power,
Uh-huh.
and then c to the second power.
And what does that simplify to?
That simplifies 9c to the second power.
Okay, and then we're going to multiply that. Okay, the next one, let me hear from Milena.
For the next one, use -2 times c
To the what power?
to the third power,
Good, and
and c and 4 times
good. And so that simplifies to?
c to
Negative.
-8 and then c to the 12.
Okay, final step, Kate.
Then you do 9 times -8.
And that makes?
-72, and then you add c to the second power and c to the 12th power and c to the 14th.
Okay, so we get -72 c to the 14th power. Questions? All right, moving on. We are going on to negative exponents. So we talked about before, okay, we talked about very quickly, there's a couple different ways. When we multiply with a common base, we add the exponents. There's 2 ways to do this, okay? So the first way is when we divide, we really subtract the exponent. So we always do top minus the bottom. Now, every situation calls for, like, people are like, can I do this way? Can I do that way? It all depends on the situation at the time. So I'm doing x to the 5th power minus, now notice my bottom one is a -4. So I use my rule of, I'm using my rules of integers. So 5 minus -4 makes what?
X.
5 minus -4 is really plus, and that really ends up being x to the 9th. Now, another thing you can do, remember I told you that when we have like x to the -2, how do I write that as a positive exponent? What can I do with that? Alan?
1 over x to the second.
We drop it down because really this is like x to the -2 over 1, and we take the reciprocal, x to the 2nd, right? Well, we can do that right here. Isn't this x to the 5th? Okay, I'm going to show you 3 ways actually. Okay. Shh. What do you mean, how do you get x to the 9th?
If you write it 5 times and 4 times, and then you take it out.
But it's x to the -4. You have to take the reciprocal of it. Okay, so that was the first way. Doesn't this really mean x to the 5th divided by 1 over x to the 4th? If I convert x to the negative, oops. Okay. Okay, I'm going to, if I have x to the -4th, how do I write that as a positive exponent? Go.
1 over x to the 4th.
So, isn't that the same thing? Yes or no, Rami? I'm waiting on you. Okay. Now, how do we divide fractions? Do we divide fractions? We multiply, right? So I'm going to do x to the 5th divided by 1 over x to the 4th. But we don't really divide. We multiply by the reciprocal. Okay, so now I get x to the 5th times x to the 4th, which is x to the 9th. What I'm saying is whenever you see a negative exponent, you can right away x to the 5th over x to the -4. We can rewrite it right away as x to the 5th, bring this up, times x to the 4th, right? You can just right away reciprocal it.
Why?
Because you can, because we're going to eventually do that. Isn't that what we do when we have a negative exponent?
Yeah.
We take the reciprocal, but instead of this time going from the numerator to the denominator, we're taking the reciprocal where it's in the denominator and put it to the numerator.
I'm just so confused why when we do the reciprocal, why doesn't x to the 5th come down?
What?
Oh, okay, I got it.
If it's x to the -4, do you understand this part? Isn't that I take the reciprocal? I move this up and I make this positive because this really implies it's a decimal.
No, I understand that.
Okay? The only difference is this time the negative exponent's in the denominator, so move it up. Does that make sense? Okay, so next one. Instead of multiplying, what are we doing? Y to the 4th power. What do we do usually?
Oh,
Add the exponents, but just use our integer rule. Y to the 4th plus -3,
That's 1.
which equals y to the 1st power. We could also do it like this. Y to the 4th power, I'm going to take the reciprocal and do y to the 3rd. Then it's y to the 4 minus 3, which is y to the 1st. So a couple different ways to do it. Yes?
So when you're dividing, you subtract them and then the exponents, and then when you multiply, you add the first place.
But you have to pay attention to the integer rules too. Do you understand? See, these are the same thing, just a different way to do it. It's it's whatever. It doesn't matter.
Well, I mean the second problem.
Okay, so let's move on to, now let's look at, now there's a couple different ways to do these, and I'm going to tell you, we can do the, right here it's kind of easy, so we can do a to the 10th power minus the third. Remember, bottom minus the top? Which is a to the 7th. But I can also do this, a to the 10th over a to the 3rd. And the bigger these get, the more we're going to need to do this. What's the greatest amount of a's we can take out of both top and bottom? Three a's. So when I divide the bottom by a to the 3rd, I'm left with 1. When I divide the top, I'm left with a to the 7th. So this equals a to the 7th. What's the greatest numerical factor in number 2 we can divide out, Devin?
Numerical factor? For the x's or for
Numerical.
2?
2. So when I divide the bottom by 2, what am I left with?
1.
1. And when I divide 8 by 2, what am I left with?
4.
4. What's the greatest amount of x's, Devin?
4.
4. I can take x to the 4th out. I'm left with 1. And when I take x to the 4th out here, what's left?
X to the 5th.
Perfect. And so my final answer is 4x to the 5th over 1. I don't need to write that. You do number 3. Go. Pause the recording. Help me out here. Numerically, what am I dividing?
You want to divide both by 3?
Good. Numerator, I'm left with a?
2.
And denominator?
3.
3. Good. Greatest amount of m's we can divide out. Shivam.
Greatest 4.
I can take 4 out of the top. I'm left with 1. And in the denominator, I'm left with?
M to the 8th.
Good. And so in the numerator, we're left with 2 times 1 is 2. And the denominator is 3m to the 8th. And here is our final. I could also write that like, oh no, I can't. I can't. M's, you can only write it as a fraction next to the m to the 8th if the m is in the middle, in the top, in the numerator.
I'm kind of confused. Like when you have 12 and 4, shouldn't it cancel out to like 1 and then
Where?
like on the end to the 4th
Nope,
and
you're
then
not
end to
dividing.
12?
All we're doing is m, like really all we're doing if this were the fraction, we're canceling out 4 that they have in common, and I have 4 left. We subtract. Do you understand? Okay, let's keep going. Please don't do that right now. Thank you. Okay, we're going to skip these. Now, negative exponents with power to a power. Same thing. Power to a power, we multiply the exponents. Now we have to use our rules of integers. The third power times negative 2 power is what?
Negative 6 power.
Good. And then could I write that as a positive exponent?
Yes.
What would that become? What?
1 over 2 to 6.
1 over 2 to the 6, and that simplifies to?
1 over.
Yes?
It simplifies to 1 over
64.
Yeah.
Thank you, Ashley. Okay, 1 over 64. So, how do they ask the question? Do they say, I want to see it with a negative exponent? Do they say, I want to see it with a positive exponent? Or do they want it simplified? 3 ways they could ask the question. Do you understand that?
Yes.
Got to pay attention to the directions. So now, let's look at stuff with a power to a power. We could have done it this way, too. Done 2 to the 3rd is 8, and then taken it to the negative 2. Let's do a couple of these. So, this is going to be 5 to the, what am I doing? Go, Bryce.
You add the exponents. So you
4
4 minus
plus negative 2, double sign. That really means 5 to the second power, and that is 25. Okay, this one is number 2. Number 2. Let's go, Ashley again. This time it's Ashley's turn. 8.
It's 8 to the, negative 2.
Good. How do I write it with a positive exponent?
That's 64.
How do I, no, it's negative 2 power. How do I write that with a positive exponent? Go.
You write the reciprocal, which is 1 over 8 to the 2, which is 1 over 64.
1 over 64. So remember, when it's a negative exponent, it's a fractional amount. Okay, now I'm doing. What are we doing first, Sophia?
You write 7 to the negative third power.
Okay, what does that simplify to?
Negative 6.
Negative 6 power times 7 to the 5th. Now I can do 7 to the negative 6 plus 5. That equals 7 to the negative 1, which is 1 over 7. We could have also done 7 to the negative 6 times 7 to the 5. I could drop it down right away. Create a fraction. 7 to the 5th stays high. 7 to the 6th stays low. When I take it out, I'm left with 1 7. 7 to the 1st down here. That extra 7 is left. Okay?
Why didn't you just like split? Why didn't you like multiply 7 times 7 and then add this? Because don't you multiply?
You could do that, but then you don't have a common base to deal with this. Don't multiply it out. You want to use your rules of exponents to multiply common bases. If you multiply it out to 49 to the negative 1 power, then you can't use your rule of exponents. And nobody wants to multiply out 7 to the 5th.
Isn't 49 to the negative 1 power different than 7 to the negative 1 power?
Well, 49 to the negative 3 power. That would be, it makes it way more complicated. Okay, so may as well use your...
No, I'm saying the 7 to the left.
Okay, that's the lesson. There we go.